Hello, everyone. Hello, Billy.
Hey,
Um, Welcome to our online event today. And we have another great guest and another fantastic topic today. Billy is with us. He is a developer working as a developer advocate at Oracle, and he is famous with his sip of Java tweets, which I really like to follow. And he is going to give a presentation about to Java 18 and beyond. Billy, hello again, and thanks being with us today. Now the stage is yours.
awesome. Thank you, Everett. Thanks for inviting me to present here at the Turkey Java community. I've been really looking forward to it. So, if we could get my slide deck. Yeah, okay, great. Thank you. Yeah, as Everett mentioned, my name is Billy Carando. You can find me on Twitter at Billy Carando, and I'm a Java developer advocate with Oracle. And we're going to be talking about to Java 18 and beyond. A few things before we get to that, though. First, please be sure to ask questions. I will be monitoring the comment log just for any questions that come up. So there is about, I think, like a 30-second delay typically between me presenting and then it actually being streamed to YouTube. So there will be a bit of delay, but I will try to keep close to it. And if any questions come up, I'll be more than happy to answer to them. And again, if you want to reach out, Billy Crandall on Twitter. Again, you can tweet at me. You can send me a DM as well. You can also email me at billy.crandall@oracle.com. And a link to the slides is here at my GitHub, wcarando to Java 18 and beyond. And I think hopefully we'll get that posted into the comments as well, so you can have an easy access to the slide deck. One last bit of of bureaucracy is, so if you leave with an intense desire to know more, check out our new dev.java. So that is a website that the team at Oracle I'm with, we put together that has great tutorials, also a way to get and connect with the community where we have like all the different Java communities around the world there, and also upcoming conferences and a lot of other great information. So be sure to check that out. We also have Inside Java, which kind of focuses on the development and progress to the OpenJDK. So if you're kind of wondering, how like I'm talking about what's coming beyond in Java 18, that is a great place to go to kind of understand what is going to be kind of happening within OpenJDK, where we're heading. Also, we have our YouTube channel, youtube.com/Java, where we also post the audio from our podcast. We also have the Inside Java newscast, which is a great way also of kind of learning about this great information. As Everin mentioned, I also do my Sip of Java. So every Monday, I post that. It's just a 1-minute video about just kind of various Java topics, just, kind of introducing Java developers to things that I kind of find sound interesting and, something they can also practically use at your day job. And then the last one also on our YouTube channel is Jep Cafe, where Jose, he kind of goes through these different Jeps in depth to really kind of explain what's going on with them. And if you're not familiar with Jep, I'll kind of explain what that is a little bit later in this presentation. So with that said, let's actually start getting into this presentation. So the agenda is we're going to be covering some new language features, new runtime features, and then finally we're going to get into some deprecation removals and other changes to know about. And then we're going to kind of get into the future of Java. Let's see. Is that correct? Hopefully that's coming through. Okay. Notice some screen tearing. Hopefully that cleared it up though. So let's first kind of cover the new language features, because I think this is kind of what most Java developers are most excited about coming, or that has been released in most recent releases of Java. And also thank you for posting the link to my slide deck into the comments. The first is text blocks. These were added in Java 15, and their JEP is 378. So as promised, what does JEP mean? So JEP stands for JDK Enhancement Proposal. And what that is that whenever there's like a somewhat substantial change that's being proposed to be added to the JDK, then there's going to be a whole write-up about it, about what's the motivations behind the change, what's going to be changing, what could be the potential impacts, and so on. So like in this case, JEP 378, if you type into the URL, and of course it's all also listed here, 378, you can get a full write-up about this new feature. So, I'll be covering these features a little bit, but not as much depth, of course, as what's going to be all covered in here. So this is always a great way to kind of really get into a lot of the depth of these new features, and also to what I was talking a little about earlier with the Jeff Cafe by Jose. He really also covers these new features really in great depth as well. So just some great resources beyond just maybe what's being covered in this presentation. So that said, what are text blocks? Well, this is one feature I'm pretty excited about, since I know there's many times in my career where it could have helped me. But at some point, as Java developers, we've all had to kind of work with some sort of like markup language, or in this case, I have JSON in here, where, this is a very simple JSON message. And, we're familiar enough with it that we can mostly understand what's going on in here, but it's still pretty difficult. We have, like these tab characters I want to put in here. We have to escape out all the quotes. We have to add the new line. So it gets very messy very quickly. And I also had to put like these comments at the end just to make sure that like it doesn't do some weird wrapping. And of course, we had something more complex. It could just be very easy to forget a comma or not have like a proper tabbing or anything like that. So it starts to get very confusing very quickly. So, now we have text blocks. And so text blocks are still just basically normal strings, but they're differentiated where you just put triple quotes at a line, then you do a new line, and then within here, a lot of the formatting requirements are relaxed. So I don't need to put any new line characters in here. All this white space here is preserved. I don't need to escape out the quotes or anything. So what we're left with then is this text blocks, if I was to print it out or kind of work within my code, would look exactly like this. And it wouldn't, I wouldn't, that's weird. Okay, there we go. And it's also encapsulated then with triple quotes as well. Hopefully, give me one moment. On my screen here, it looks like there's some screen tearing going on. And I'll just bring up the YouTube stream just to make sure. I don't know if that's StreamYard or also YouTube, just to make sure that things look correct. But yeah, so we'll see here how all the formatting is reduced, and basically this string looks like as it would actually be printed out as well. As I mentioned, though, these are fundamentally normal strings. So a lot of the string API will still actually work with a text block as it would with a quote unquote normal string, because really underlying this all, it is just a normal string. And okay, yeah, that is weird. Okay, I'll be sure to watch that to make sure I get these slides cleaned up. For some reason, it's not refreshing properly. But to continue on, but if you wanted to do like a formatted string here, and to pass in some values like I am here, that works just as well. Also, if you were needing to do like a really long single line of string as well, in this case like this, I just wanted this lorem ipsum line just to be printed out all in a single line. You can just add a backslash to the very end of a line within a text block, and then that will ignore the character turn. And so then this line would just be printed out as one single long line. The next I want to cover is the switch updates. These were added in Java 14, and their JEP is 361. So what changed here is, so we're all familiar with switch statements, and we can have like this really basic one that's kind of covering all the different days of the week. But it's kind of messy where we have to have these break statements in each of the cases, because switches, they had that fall through by default, which is typically not desirable. So it makes this kind of messy to look at. And then it can also make it very easy to introduce a bug, because we can, accidentally forget to add a break statement, or maybe we commented out or something like that happens. And then all of a sudden when we, hit on case 6 for Fridays, then we also fall through and also print out Saturday. And that's, rarely the case where that would be desirable. So now we have this new arrow syntax for switches where now when a case is matched on, only the code to the right of a statement is going to be executed, and there is no fall through. So not only is this much cleaner and much easier to read, it's also much more reliable. So I think that's also one of the important things, because Java, both rightly and wrongly, gets to knock a bit of being overly verbose. And here we see an example where, we're reducing verbosity, but it's not just beneficial because like it's a little bit less typing, which is nice, but not that important usually, because that's usually not the actual typing out of code usually isn't that what consumes most of our time. But now it's much more reliable. There's less opportunity for breaks in there because we're not having to add a bunch of this extra structure in there just to get something to work correctly. So also with these switch updates, though, is a switch can also behave as an expression. So now instead of, maybe having to do the system out print line for each of these cases, I could just actually return a value from these, in this case, a string, and then, have it down here to actually have that be printed out. So again, this is, even cleaner. Now, when you're running it as a switch expression, they have to be exhaustive. So here, I would have to have a default because, I'm not covering all the different numbers. And even if I did, we'll be getting to those pretty soon, records of pattern matching. Because we're not covering all the numbers, and even if we did, that still doesn't count as being exhaustive. We would have to include a default statement, which in this case could also be a throw. But also if you wanted to, like, let's say you wanted to use the new arrow syntax, but you had to also maybe execute a few lines, then you can also still write a block of code in here, and only this code would be executed. If you're running it as an expression, then you would have to end that statement, that block of code, with a yield. And also this yield syntax, are writing code as expression, still also even works with the old colon syntax as well. So you can still write an expression like this if for some reason you're just maybe more comfortable with the colon syntax than you are with the arrow syntax. But as I mentioned, when you're writing it as an expression, they have to be exhaustive. So here, because I have an enum that's just, again, covering all the days of the week, because I'm covering all the different values within this enum, that is then exhaustive. So I don't need to provide a default case in here. And of course, that would also work exactly this, more or less exactly the same as it would with the older colon syntax. So next, as Mustafa was mentioning, we have instance of, and the first instance of pattern matching, or not, now we have pattern matching, and the first example of that is with instance of, and this was added in Java 16, and the JEP for it is 394. So again, another thing we're all very familiar with as Java developers is this, we have some sort of type that we just don't maybe know the exact type of it. In this case, like, okay, this, I have as an object, but it's actually a string. And so we have the value of actually a string. And then we have our if instance of a string, then set it to a string, and we have to do the cast, and then we can do whatever we want with it. Again, it's somewhat verbose. If I was to have many examples of this, where it could be a string, it could be a person, it could be, any other number of different types of objects or different types of classes, it would start to get pretty messy to look at. So now with pattern matching for instance of, what we have is you would have a check to see, okay, is this object actually a string? And then if it is, it would assign it to the pattern variable, now I'm a string, and then we can kind of work with it within the block. So this is what's called pattern matching. If you're not familiar with that, what it is where you would have a predicate, and again, in this case, we're doing instance of, and then you would, if that predicate is true, then that value would be assigned to the pattern value. the pattern variable. So also with this comes a new concept to Java, or at least something that's going to become more common, which is called flow scoping. So what flow scoping is, this now string variable is in scope wherever the compiler definitely knows it has been set, or basically wherever this predicate is definitely true. So right here, now string is in scope, and then it's going to be in scope for within the if statement, but it's going to be out of scope once we leave this if statement. Somewhat similarly here within just this evaluation, now string, of course, is in scope, but the second we leave it, it's going to be out of scope. So this is in scope wherever, again, the compiler definitely knows this is to be true. So again, example of that then is here. Now string would be in scope here, but it's not going to be in scope to the right of this R statement, because, well, by necessity, you would only get to this right part if this check was false. Yep. But, oops, sorry. There we go. But it would, of course, be then in scope to the right of an AND statement. There's a few weirder things you can do, like, if I was to put a not within this if, it wouldn't be in scope following the if, but it would be in the else. Or if I was to do this with like a not and then a throw, then it would be in scope outside of it. But, I wouldn't recommend doing this stuff because that would be very confusing to someone else reading your code. Many cases is where you're going to need is just to have some other variable at the appropriate scope and then set it within the if block where you're doing your instance of. All right, the next is we're going to be talking about sealed classes. These were added in Java 17 and their JEP is 409. So sealed classes, so at every organization we have worked at, you spent some time with, there's going to be certain like domain concepts you're going to be familiar with that, you're going to have like maybe customer types, transaction types, account types, something like that, where there could be only like a pretty limited variety of that. And sealed classes are a great way of kind of putting that information into code, where you can have a super class and it can define what kind of classes that can actually extend off of it. So in this example, I have like a user type. And this user type is saying it can only have 3 subclasses off of it: guest, customer, and admin. Now, what did the outlines around these boxes mean? So in this example, like what this dashing means is that it's a sealed class. And so that means it's saying what can be a subclass of it. A solid line, this is like a final class, so nothing can extend on it. Customer, it's going to be a non-sealed class, which basically makes it a normal class where anything can extend across customer. So maybe there's just so many different potential types of customer, you don't really want to have to limit it by defining that in customer. And again, with admin, it too could also be a sealed class where it can only permit a couple of different types of admins to extend upon it. So what does this look like in code? In code, this would look like we would define our user class and we would use a new keyword, sealed. And then we would have the optional keyword, permits, where we then say admin, customer, and guest can extend off of sealed class or off user. So then these subclasses of admin, guest, and customer, they would then, within their declaration, have to say if they are a sealed class, like it is with admin, a final class, like it is here with guest, or a non-sealed class, like with customer. And again, when it's non-sealed, that basically makes it a normal class where anything can extend off of customer. But like I said, this is a great way of being able to embed kind of important domain information about your organization within your code, because like I said, I know there's been many times at organizations I worked with before, there would be, again, these concepts that there would be a limited number of different like subtypes for something, but there is no good way until with now a sealed class is to actually convey that concept. And we'll see also here soon how we're going to be kind of building more upon these concepts in future releases of Java, which again we'll cover here in just a few moments. So the last change, and definitely not least, is records. As Mustafa was mentioning earlier, I think this is probably going to be like one of the biggest changes coming to Java since the introduction of streams and lambdas back in Java 8. So records were introduced in Java 16, and the JEP for them is 395. Yeah, so a non-sealed class is effectively the same as a normal class. Yeah, there's no real difference. It's just a case with when defining a sealed class hierarchy, you just have to define those subclasses as whether or not they're sealed, final, or non-sealed, and which again basically makes them normal. But yes, it helps with inheritance, restricting inheritance. So it allows a class, so user can define what classes can extend upon it. So only these classes are allowed, admin, customer, and guest, to extend upon it. If I was to try to create like another user type, like super user, that would result in a compiler error unless I updated user to permit also super user to extend off of it. Great questions and comments. And again, if you have any more questions or comments, please write them and I'll try to get to them as well. But again, to back to records, add in Java 16, JEP 395. So there's many different advantages to records. Probably the most and first that most developers will notice is helping to reduce verbosity. So like, let's just say this is the body of a method. So like imagine like the curly braces outside here. But like I'm bringing in like several different fields, and like I need to put these fields within some sort of object, and like maybe if this object would only really make sense within the context of this method, I don't really need it anywhere else. So if I wanted to do that, like I would have to define like this class, and even the most simple of classes quickly take up, dozens of lines of code just to define like the hash code equals toString, the constructor, and all of that. And so when this happens, you quickly kind of lose all meaning within this method because it's just so distracting to look at. So now we have records where all of this, which I know this is kind of hard to read, kind of intentionally so, can now be defined within a single line where we define the name of the record, the fields are the components of this record, and then we can then work with it here immediately later in the code. So records, they're not just about reducing verbosity though. They are the goal of records is to be a transparent modeling of data as data. And so with that, there are some specific constraints on records, which, limit what you can do with them, but it's also then allows a lot of the compiler and a lot of other features to kind of build upon these constraints because they kind of know what they could and couldn't be. So as I mentioned, transparent modeling data. Record is always going to have the superclass of Java. Whoops. Sorry about that. These magic mouses can be very annoying at times during presentations where they can be very fidgety. And then also with that, so because the superclasses also can only be Java lang record, they can't be extended, they can't be abstract, and they are implicitly final. Let's see, we have a question. Will we have to declare sealed classes in a specific class? So I guess any class could be sealed, and then I'll also touch it here in just a second. So, and then when you define a sealed class, you would have to either provide a permits clause, which defines all the classes that could extend that superclass or that sealed class, or within that same class file, you would define all the potential subclasses within that file for that sealed class. And I'll have an example here in just a moment, also with this records example. But yeah, great question. But back to records. So yeah, they can't be extended, they can't be abstract, and they're implicitly final. All the fields are final, but it's only shallowly immutable. So for example, let's say you defined a record that had an array list within it. There's nothing within the mechanisms of a record that will prevent you from adding or removing elements from that array list. But of course, you couldn't actually change out that list for a completely different instance of the list because that would violate final. You can also not declare instance fields within a record. The accessor, hash code, toString, and equals, they're all automatically generated, but all these can be overridden by, or you can override these default implementations or even add your own method definitions, because in the end, records really are just classes. But of course, make sure when you're overriding accessors, hash code, toString, or equals, or any, or not toString this much, but equals, hash code, accessors, that you're not in some way violating that contract with it. Like you're not, you have an accessor that returns just some random value, or you're doing equals, but it's not like actually really comparing all the values, because that's going to then lead to a lot of potential issues. But maybe for some reason you do need to override those. Just make sure you're not violating the fundamental contract. Yeah, I think someone's mentioning records have limited usage because they're final, can't be extended like long. But so records just exactly. You're not going to use them for everywhere because they are about handling data, specifically immutable data. And so like there's some things where if you're doing like JPA, like a record is not and never will be an entity, because an entity will need to have immutability to them. And there could be many other areas where if you need to be able to change some of the code about it or some of the values within it without creating a new instance of it, then of course a record isn't for you. So yeah, it definitely, you shouldn't be thinking like all of my, POJOs, my plain old Java objects are going to need to be changed out to records. They do have specific use cases for them. But I think there will be many use cases. Part of this is because, I'll get to that about serialization just a moment. But because microservices, lambdas, serverless functions, and all becoming much more popular, you're more often writing applications at the very edge of the data boundary, and that can be very useful when reading in like a JSON message and converting it, and then maybe printing it out or sending it on to somewhere else. Records be very useful there. So then Mustafa also asked, but records, do they have advantages for serialization? Yes, they absolutely do. So serialization is a very frustrating area within Java. It's kind of, I think Brian Getz described it as like one of the biggest mistakes in Java, just because there's so many potential security issues. I don't think I really touched it too much in this presentation, but like a big issue with serialization for normal classes is that they don't actually use the constructor when recreating or deserializing a class, which could lead to a lot of invariance. So like maybe within a constructor for a class, you have something that checks to make sure like a field can't be empty, like can't be an empty string, or you have like a number field that can't be below 0, or can't be below some number. When deserializing, that constructor isn't called, so that could be very easily where you have some new object that is violating those constraints, and it can lead to a lot of issues within your code. With records, a records constructor, its canonical constructor, is called, so any checks you maybe have within that are going to be done to make sure that you don't have some sort of record that's violating some of these constraints on it. So that's like one key advantage. There's several other advantages that also avoid a lot of the other security issues with records as well. Again, another great comment about that. So a little bit more about records. Let's just kind of finish it up here. So as I mentioned, you can override some of these provided implementations. Like, so here, toString, I could just override it here if I wanted to. I can also add my own methods to it. Like here, I want to maybe have something to handle to JSON. I can write that in there. Like I said, fundamentally, they are also normal classes at the end of the day. So that's something that's also easy to work with. And thank you. I'm glad my explanations helped explain what it was, some of the advantages of records. And the last thing is that records, so records, as I mentioned, you can't extend them, but they can implement interfaces. So if you wanted to combine records with sealed classes, you can do that through an interface. And of course, interfaces can also be sealed. So like in this example, I'm using my user and it's a sealed interface. And then also in this example, so you notice I don't have a permits statement in here. And like I said, that's optional. And if you then define all the subclass, or if you define subclasses within that same source file, that will automatically be interpreted as the only classes that can extend, or in this case, implement this sealed interface. So if you want that invariance provided by records with that, the benefits of a sealed classes, you can be able to do that with interfaces. And also maybe one last thing just to touch upon. So like here within this record, if I try to define a new field within it, that would also get a compilable error. That's like a new instance field. And if I also tried to like define like first name, sending it to like some default value, like, John or Billy or whatever, that would also give a compile error. And the goal and the reason why is it gets back to that transparent modeling of data as data. So you want to be able just to read the definition of a record and instantly know these are all the fields of the record that when you call a constructor for that record, the fields are going to be set to that, or you're going to get like an exception because maybe it violates something. But like I said, it's supposed to be a transparent modeling of data as data. Oop. All right. And the last new code change I want to talk about, this is going to be something that's going to be coming in Java 18, is you can now put like better support for code snippets in Java API documentation. Like I said, this is going to be part of JDK 18, and the JEP for that is 4.13. And so just covering the very basics of it, but there's a couple of different ways you can handle it. You can either within the Javadoc itself provide the code for it, and you just start it with a curly brace snippet, then colon, and then in here you would write out whatever code you want to have defined within your Javadoc. Or you could also do it externally where you reference some method within a class file, in this case, the so-optional method within the so-optional Java file, and then you would say like the region of example here, and then you would provide comments to start and end, and then anything within this would then be within the Javadoc. And then, of course, as this changed, that would automatically update the Javadoc. So that's going to be a pretty cool change if you ever kind of have like some sort of complex code or something like that to put that into your Javadoc. And also with this change, it's a lot easier than having to kind of work with that pseudo HTML that Javadoc does. And then tooling will be better able to understand that this is code within here than it currently is able to. So let's leave language features and let's get into some of the new runtime features and improvements. So the first I want to cover is CDS updates. CDS stands for class. Oh, sorry, I just saw your question. So can we use record class for configuration class? Yeah, and that probably would be a pretty good example for something you would want to use a record class for, because generally configuration, you're not going to have a change once you actually initialize an application. So, that could be a pretty good example for doing that, a pretty good use case for a record class. for CDS updates, what this stands for is class data sharing. And so class data sharing actually goes all the way back to JDK 5. And pretty much what it was is that whenever you start up a new JVM, the JVM will load some core classes from the JVM into memory. And because it would always be loading these same core classes, that was a real opportunity for optimization. So CDS, initially introduced in Java 5, provided like a pre-processed file that allows for a quicker loading of these core classes. Then in JDK 10, we added what was called app CDS. So the CDS initially was just only about core Java classes. Now with app CDS, that's application class data sharing, we extended that benefit to actual application classes because most of the time when you're going to be loading classes, it's going to be coming from your application classes. So that's going to really extend the benefit because CDS was maybe only saving, like 0.2 of a second off your startup time, whereas application CDS could save much more significant amount of time. So in JDK 12, they also added a default CDS archive. So now everyone always gets access to this core CDS. And in JDK 13, we made app CDS a lot easier to work with by just providing 2 commands that you just do Java archive classes and exit. You give a name of your what's called a shared Java shared archive, and then you would have the command to start your application. And then to read from that shared archive, you would just say XX shared archive and then reference wherever that location is on your system. And again, just start your application as normal. But there can be there can be pretty significant benefits to this. Like, of course, if you're trying to, actually connect out to services like a database, a cache, or some other service, that could dominate a lot of the startup time. But if you're not doing any of that, like I did some examples where I was just like starting like a pretty basic Spring Boot application, and AppCDS reduced the startup time, but I think by about like 20% off of it. So like if it was like taking 15 seconds to start up beforehand, with AppCDS enabled, like it was maybe coming down to like 12 to 13 seconds. So a non-trivial improvement off of the original startup time. There can also be benefits when it comes to memory. So this shared archive will be memory mapped, and then all the other JVMs can know to also use this shared archive if you're telling it to use this dynamic shared archive as well. And that will all reference the same memory location. So if you're having a bunch of instances of an application running in parallel on the same machine, that can also have some memory savings. But again, that's only if you're having multiple instances of it. If you're just running a single instance on a machine like you maybe typically would in a Docker container, you wouldn't really notice a memory improvement. And I haven't really tested out if you could use like a shared volume just to reduce memory usage, because I'm not sure if that would work properly within a Docker container. So a lot of times, you maybe want to get a memory savings, but if you are running multiple applications in parallel on the same machine, you can see some there. The next is ZGC. Z just doesn't stand for just the last letter in the English alphabet, and garbage collector. And so this was gets made generally available in JDK 15, or was no longer experimental in JDK 15. And it's just a complete redesign of garbage collection on Java. Currently, it's single generation, which only means something if you're like really deep into garbage collectors. But currently, all the other garbage collectors, G1, and parallel garbage collector, and serialized garbage collector, they are all multi-generation, where like a newly created object just put into a special region, and if it lives for a while, then it'll move to another region. If it lives for much longer, go into another region. It's a way for handling memory a little bit more efficiently. Right now, ZGC is single generation, but it might become multi-generational in the future. But the goals of ZGC is to have extremely low latency, so 1 millisecond or lower pause times, which is really helpful for web applications because you want to have as quick as a response as possible. But if you're doing some sort of like batch processing, there might be some reduction in throughput compared to G1. So you just have to kind of tune that in those kind of use cases. So yeah, web applications, ZGC would definitely probably be a better choice. Other things where throughput is much more the goal, you may want to kind of compare that to some of the other garbage collector options. It's also scalable. It can handle multi-terabyte heap sizes. But to use it, to compare that to some of the garbage collectors, you can just tell it to use ZDC. You can set the size, and you can then have like debug garbage collection logging set as well to kind of really see everything that's going on. And to your question, Mustafa, yeah, G1 is the still default garbage collector in JDK 17. And it was, for everyone else, that was made the default garbage collector back in Java 9. If you're on Java 8, the current garbage collector is parallel garbage collector, but G1 pretty much provides better performance in almost all use cases. So that's why it was made the default in JDK 9. So this is a change that I think every Java developer is going to be so excited by. This is helpful null pointers because we have all run into a null pointer at some point in our development life. And then you have to go in and add some sort of log statement to try to figure out what the null pointer is. You figure it out, and then you actually push the change. So you have to do like 2 production pushes to, finally fix whatever issue you're trying to figure out. So helpful null pointers are much more helpful. So here, of course, the old null pointer we're all familiar with, where it just tells you the line that the null occurred on. But now, with helpful null pointers, it will actually say what variable, in this case, local 1, that actually resulted in the null. So, a very big improvement, saving a lot of frustration whenever those inevitable NPEs come up, that now it will actually give much more helpful information as to what actually happened, what actual value was null. Another thing, so the the AArch64 architecture is now supported across all the major operating systems. So Linux was the first with JDK 9, Windows came next with JDK 16, and macOS came with JDK 17. So hopefully one of these days I get one of those really nice M1 MacBooks, I'll be able to really take advantage of this new ARM AArch64 support. So my machine will maybe run a lot faster when I'm writing code and running applications. The last of the major changes I want to talk about is there's going to be a new simple web server that's going to actually be packaged with JDK 18, and this is JEP 408. Yeah, it will save a lot of lives for sure. Yeah, the helpful NPEs. That's funny. So pretty much the goal of the simple web server is to provide a way of serving files with the absolute minimum possible ceremony. Of course, there's many web server options available already, but you have to go out and download something and to run it. Now we want to have something that's actually packaged in there that doesn't require any configuration. So to start the web server, you just simply type jweb server, and the default address for that will then be the loopback address on port 8000. And then whatever files that are in the directory where you start a JWeb server from will be served by the simple web server. And so there's some already MIME types that automatically configured. So if you have a HTML file in that folder, then it'll be rendered as HTML. But if you have something like a Java file within that folder, it'll be rendered as plain text. But you can also customize that via the Java Net URL connection get name map API. You can also do other configurations as well. So if you want to have it run on a different port, you would provide -p, a different binding address, -b, different directory, -d. If you want different kinds of output, you can have either none, the info is the default, or you can have verbose. And if you need help, you can also do -H. So the last, but definitely not least, is also there's a lot of just general performance improvements. I keep forgetting I need to rerun this test with Java 17, and I haven't yet. But pretty much, if you're familiar with it, there is the Spring Boot Pet Clinic application. And in this case, I was using the 2.4.5 example. And like I just sent a bunch of requests to it, and like I just set like a minimal heap size and made sure we're both using the same garbage collector as well. And so for the startup of the application on my machine, it took 8.665 seconds. And then with just running the exact same binary with Java 16, it dropped down to 6.452 seconds. And then the actual load ran a little bit quicker with Java 16 than it did with Java 8. But I think one thing to keep in mind, though, this was the exact same binary. It's not like, oh, I had to go through and like update all my code and recompile or do any of that. No, I could run the exact same binary and unlock these benefits. And, it's going to, of course, vary based upon your application, your machine, and a lot of other variables. But you should see a pretty noticeable improvement across all the major performance metrics of like startup, throughput, memory usage, latency, and all that. Like all those probably you should notice noticeable improvements. And again, how much will kind of vary. Will memory segment released for Java 18? I'm not quite sure what you mean by that question. Let me see. We can JK 18. Are you referring to the foreign function and memory API, maybe? In which case, that's going to just be still in incubator status. Otherwise, I'm not quite sure what change you might be referring to there. Let's see. Another, if you can maybe explain a bit more, I can maybe try to answer that. Is JRIP server only available as a separate tool? It will be. It will be packaged with the JDK itself. So with JDK 18, it will actually be part of the JDK itself. So there's not going to be some sort of separate tool or anything like that. Yeah, exactly. You will be able to start a web server program adequately within your app without starting an external dependency. Yeah, and there's also a programmable API for the new simple web server that I just don't quite have time to get into. But I did do a video about it on YouTube. One of our Inside Java newscasts. So give me a second to bring up that link. I probably should have actually included the link in my slide deck. But here we go. But yeah, back in early December, I did a presentation or did a video, one of our Inside Java newscasts, where I saw a little bit of a funny bit, but I cover the simple web server, how to use it, and then also how it could be modified as well. So you can check that out on our YouTube Java page, and it will be on here as well. And all right. So the last kind of major thing is I want to get into deprecation removals and other changes to know about. And so the security manager is being deprecated for removal of JDK 17, JEP 411. The specific shape of what that removal will look like is still a little bit up for discussion, but generally it's going to be removed just because Security Manager, ultimately OS controls can better handle that than they could through the JVM. The applet API is also marked for removal. Back in JDK 9, it was deprecated, but now it's actually going to be marked for removal from the JDK itself. A couple of things that actually have been outright removed is the Nashorn JavaScript engine. It's still available, like out under OpenJDK. Like there's still a binary you can bring and still use with it, but it's no longer part of the JDK itself. The CMS garbage collector, the clear mark sweep garbage collector, that was removed in JDK 14 because fundamentally the G1 garbage collector is just better in basically every way than the CMS garbage collector. Some other changes, is that the JDK will be strongly encapsulated by default, starting with JDK 17. So that means illegal access permit will no longer work. But there's still some APIs like the Sun Mist Unsafe and a few others that are still available that you won't have to use this illegal access permit to get to. Eventually, the illegal access permit flag will be removed altogether, so you'll get a runtime error. But you can still, of course, do the add opens to that to your to the command line or to a jar manifest. Also, one other thing, so like I'm covering like some of these more significant changes, but also with every release, usually there's going to be some new classes, some fields, some methods as well that can be very helpful. And what you can do now is here in this case for like early access for JDK 18 is you can go to this link and there's like a new modules and new packages and new interfaces, which covers like all the changes that have been added since JDK 11. Not sure why that's going black. But you can kind of see all those little changes as well, which can be very helpful to see what has been changed, what has been added. For example, the string API has been significantly updated since then. Everin, do we have like a few more minutes, or is 12 like a pretty hard stop?
It's okay. We have one more or 2 more minutes, Billy.
Okay. Okay, I'll quickly finish this up. So I just want to touch a little bit on some of the future changes coming to the JDK in the next few releases. The first is pattern matching for switch. So this is going to be the second example of pattern matching being added. And this is going to be a second preview for Java 18, and it should be delivered then as a GA feature in Java 19. But now for like a switch statement, if like you can have it match like upon classes and then set that to like the pattern variable of I and then work with that in the following case statement. Also, you can do guarded statements. So like, let's say if it matches on the type of triangle, and then you can also say, okay, we set it to T, and if T has like an area of greater than 100, then, we'll print a large triangle. And if it doesn't, then we'll print a smaller triangle. One thing to keep in mind is you can't have domination of subsequent cases. So like I couldn't put triangle T before this one because by necessity, then all of them would, follow into that. It would be kind of like with throw statements or something like that, where you can't have like throw exception as the first one and then like throw illegal argument as a second one, because it will always hit throw exception and never fall through. Also, with pattern matching for switch, we can now do both null or handle nullability. And then also pattern matching for switch will mean it will also understand sealed hierarchies. So in this case, I don't need to have a default case because it knows I'm covering all the possible different subtypes of user of admin, guest, and customer. Because that's the only allowed subtypes of users, so I don't need to provide a default case. So that's pretty nice, and a bit of some safety and other important issues as well being covered. So if I didn't cover, like if it didn't have admin or a guest in here, this will result in a compile time error. And the last thing, also record patterns for array pattern for records and arrays. and I won't go through this too much, but pretty much what it'll allow is for an easier destructuring of records, where you can quickly just reference the fields within a record without actually having to reference the instance of it. And also with arrays, you can reference a specific element within that array without, again, having to maybe like create like a for loop and then go through that in that way. So certain times I won't be able to get through it all, but you can also get early access builds here at JDK Java.net 18. Also, we have these other projects like Loom, Panama, and Valhalla, where you can get early access builds to see how they may work with your applications. Actually, I need to update this link, but that'll be to Java 18 and beyond. But there's just like some other great information in here, including this really great article from an engineer at Netflix on how he was able to help his team and organization to upgrade past Java 8, because there's been like a lot of concern about being able to upgrade past Java 8. And mostly it becomes to just updating your dependencies. So with that, yeah, have maybe a few more questions, a little bit more time for any questions, but thank you for coming to my presentation, and thanks for all the questions as well. Oh, and also to go back to the foreign function memory API, yeah, that, like I said, it'll be in second incubator status. So somebody can kind of work with, but when something's an incubator, it's in a separate part of the JDK, and the API is subject to change. So it's something to kind of work with, but also just kind of keep in mind that that API is still subject to change. So, all right.
Thank you, Willy, for this great presentation. By the way, we have just one question in Turkish in the beginning of the slides. Let me ask it also. Just assume that you are starting a new project from scratch as of today. So which version you will choose? 11, 17? I don't know. It's related to long-time supports also.
So for me, I would always be happy to use JDK 18, but yeah, for most organizations, I would highly recommend to use Java 17. As you see, there's a whole lot of new great features that came since then, and of course, performance improvements. So if you can use JDK 17, highly recommend it. But use as late or as recent as version as possible to take advantage of all the language features, runtime features, and improvements. I would use 18, but I can understand from organizations why that might be not as practical.
Thank you for the answer, Billy.
Absolutely.
I don't know if there are other questions, but as I see, you also answered all of them during the presentation.
Yeah. Great. Thank you for everyone for joining me. And again, feel free, if there's another question didn't get to, just didn't have time to think about, DM me on Twitter. My DMs are open. So I try to check to make sure, check the DM requests sometimes coming in and to answer any questions that may come up. So happy to answer them. And thank you again so much. And thanks for the invitation. And hopefully I'll be able to do face-to-face at some point.
Yeah. Thank you. Thank you, Willy, for this great time, for this 1 hour. And
absolutely.
And thanks everyone joining today.
Cool.
Thank you.
Right.
Bye-bye.
Have a good one.